Hey folks! In this video, we're going to learn about Python's data analytics library called Pandas. This is a beginner tutorial that aspires to teach you some fundamental principles so that you're inspired to continue exploring Python. Today's lesson will cover how to declare variables and data types, how to build lists, how to build dictionaries, how to build dictionaries with lists, which is also known as associating keys with value pairs. We're going to learn how to import the Pandas library. We're going to learn about building data frames with lists, sorting data frames, replacing values, adding columns, dropping columns, using merge to add columns, learning how to add rows, learning how to search rows, and then briefly touching on how to use math functions. I believe that learning Python is one of the most impactful decisions a modern professional can make. My career greatly benefited from learning it, and my hope is that this video provides a similar benefit to you. So to get things started, Python is a programming language. You can implement Python in various environments, including script files, notebooks, and the terminal or command line. My personal preference is to code in script files, and my preferred editor is PyCharm. Another popular editor is VS Code. This lesson is going to take place in a notebook. So that's what you're looking at here. This is a Google Collaboratory notebook. I wanted to craft a tutorial that minimizes the barrier to entry so that you can overcome the friction that comes from learning something new. So I decided to go with Colab because it's Google's version of a Jupyter notebook, which means that it's free as long as you have a Google account. So in order to do this tutorial, all you need is a Google account. But if you have, a script editor or a Jupyter notebook or any other environment where you want to use Python, then all of this code will work as well. And just a caveat, I typically don't code in notebooks, so if I make minor errors along the way, I hope you'll excuse them. So with that out of the way, why don't we talk about the process for creating your first notebook? So if you haven't already, navigate to Drive. Feel free to pause the video and then resume once you're there. We're going to go up to the upper left-hand corner and we're going to select New. We're going to go to the More menu, and then you'll find Google Collaboratory there. I don't believe Google Collaboratory comes pre-installed for most Google accounts. So if you don't see Google Collaboratory here, you can go to the Connect More Apps section, navigate to the search bar, and then start typing in Colab, and then Collaboratory will show up. You can select this icon here, and then you can install it pushing this button. Once you have Colab installed, we can begin. So we're going to go back up to that New menu in case you haven't done this yet. We're going to go to More, and then we are going to select Collaboratory. So before we talk, maybe I'll introduce Pandas. Pandas is a data analytics library. It's called Pandas because it stands for panel data, which means that it formats values in a row and column format similar to a spreadsheet. With that said, Pandas is much more powerful than a spreadsheet, and it will fundamentally change the way you approach your data work. Now, with all that out of the way, let's begin. So we are going to change the name of our notebook. You can call it whatever you want to. I'm going to call mine Python for Beginners. Actually, I'm going to call it Python Pandas for Beginners. So the way that this environment works is, and I think I might have spelled this wrong. Whatever, it doesn't matter. So the way that notebooks work is you have cells. So you can run cells individually, whereas in a script file, you run the entire file. Now you can add breakpoints into script files, but the point is that with a notebook, you can store things to memory so that you can open up new cells in order to execute certain blocks of code. Before you can begin executing code, you're going to have to connect to a runtime. I don't think you have to manually do this. Like if you push the play button over here, then I believe the runtime will engage. But just for the sake of doing it, all you have to do is just select connect, and then you'll see these three dots here. You'll see that they go green, and then we will have RAM and disk coming from Google's compute engine. Cool. So I'm going to add text cells so that I can organize each module in this lesson. Feel free to do so if you want to. The one reason that I like it is that when you format a text cell, like I'm about to do, so I'm going to say how to, no, you know, we're going to start with how to declare variables and data types. So I'm going to highlight this, I'm going to hit the bold, and when you have the double T's like this, it'll provide you with this little ledge here. So you can see you can hide these cells, which I think make the notebooks easier to read. And that's one of the first tips that I would provide to anybody who's beginning programming, whether it's in Python or JavaScript or any language. Readability is one of the primary goals. So it doesn't matter really how you code as much as the ability to read it and allow others to read it. Because if you have bugs, you want to be able to scan things and quickly triangulate where the issue is. But more on that as we go along. So we are going to begin, like I said, with declaring variables and data types. I think learning about data types is just a great skill to have. Especially as you become more advanced and you try to do more sophisticated things. Figuring out how to massage the data to accomplish your goal is going to be one of the primary challenges that you face. And understanding the data type that you're working with is going to help you understand what you need to do to accomplish your goal. So I'm going to introduce 4 of the primary data types that I work with. So we're going to begin by hitting the hash sign. This is how you leave a comment in Python. And we're going to write the word string, and that's because our first data type is going to be a string. So in addition to creating a data type, we are going to declare a variable. Variable declaration is so easy in Python. All you have to do is type a variable and then use the equal sign and then define it. So in this case, we are going to define the variable x with a string of hello. So that's it, right? Like if you've watched any of my other videos, we do a lot of Google Apps Script programming, which is Google's JavaScript language. And you have to use a prefix such as, or not prefix, but like saying var const let, then your name, and then setting it equal to. In Python, you can just say x is equal to hello. And then when you print x, you'll get hello. So I just ran my cell. I'm on a Mac. I was using Command Enter. I apologize because I haven't used a Windows machine in quite some time. I would presume that it's Control Enter is the hotkey, but you can probably find that by hovering over the play button here. You'll see that it has the Command icon or Control plus Enter. That's how you execute a cell with a keyboard shortcut. Now, in addition to typing the word print, within a notebook environment, you can just type the variable like this, and it will also log out whatever variable you're referencing. My preference is to use print, which again is because I work in script files, so you have to type print in order to get logging. The next variable, or my apologies, the next data type is an integer. So we're going to use y, and we are going to set that to 10. An integer is a whole number. That means there are no decimal points or anything like that. So if we print this out, you'll see we get hello and 10. Now, if you do have a decimal point, then that will be defined as a float. So we're going to use the variable z, and we're going to set that to 10.5. There is a difference between integers and floats. So there might be some times where you're looking to work with these two and you have to massage it so that the data types are the same. So you have the ability to either cast something as a float or an integer. a float being a number that has a decimal point, and an integer being one that does not. The final data type that I think is important for you to consider is date values. Dates are very difficult, just being honest with you. The formatting requires quite a bit of massaging, but dates are structured as strings. So you'll notice that our string value requires single or double quotes, while our number values of integers and floats do not require my apologies, quotes, single or double quotes. I think we'll touch on dates in a later video, but dates are challenging because of the way that they're structured relative to computer programs potentially thinking that you want to do math with them, or them being a serial code, or all these various things. So once you get the hang of it, working with dates is fairly easy. But I would say that the majority of cleaning that I have to do is relative to formatting or reformatting dates, so that various use cases are able to manage them. Our next module is going to be focusing on lists. So I'm going to create a little text box here that says how to build lists. Then we're going to add a code block, and we will begin with a comment that says one-dimensional array, parentheses, aka a list. So you don't have to add these comments if you don't want to. I'm doing it because I think it's good to do, and hopefully it's helpful to you. So I'm going to declare a variable of list_1, and I'm going to set that equal to square brackets, and then I'm going to add a string where I'm going to use the word one. You can use any word you want to. The things that I type in here don't matter. I just want you to see how lists are structured, so feel free to do whatever you want to. So the first value, we're going to do a string, we're going to do a comma, and the second value is going to be an integer. The third value is going to be a float, and the third value will be a date. Again, these can be any values that you want to. We are going to print list_1. So that means we're going to have the word print and then a parentheses and then list_1 followed by a closing parentheses. So the reason that this list is also known as a one-dimensional array is because there is one set of square brackets. So you can see our values are comma separated, and they are enclosed by single brackets. That means that there is only one dimension with which to access each value. Lists or arrays are what's known as being zero indexed. That means the first value in the list is 0. The second value is 1, the third value is 2, and the fourth value is 3. So if you're in a spreadsheet, you have row 1. That's not how lists or arrays work. The first value is 0 followed by 1. So when you're working with a one-dimensional array and you want to access a value within that array, also known as a list, you can do so by referencing the variable, in this case list1, adding square brackets, and then entering in a value. So again, this is 0 indexed and we have 4 values. That means we could enter in any value any number between 0 and 3. So I'm going to enter in 0 within my square brackets, and when I run the cell, you'll see that 1 is returned. That's because 1 is the first value in our 0 indexed list. If we enter in 2, that will return 2.3 because 2 is the third value of 0, 1, 2, right? So you can see 2.3. If we enter in 1, we'll get 2, which I apologize, I'm sure that's very confusing to just think about. But long story short here is that The reason that lists are known as one-dimensional arrays is because there's only one dimension to access. Now, in addition to, and a quick shortcut here before we move on to the next thing is if you do command/, that will comment out a line that you're highlighting. So I'm going to comment out our print statement for now. Commenting things out is a helpful way to kind of manage code that you potentially don't want to run again. So, instead of deleting something, you can just comment it out. But again, it's about readability. So if you don't want to have if you find this to be distracting, feel free to delete things if you want to. So in addition to one-dimensional lists, we also have two-dimensional lists, or two-dimensional arrays, also known as a list of lists. So the way that we could develop a two-dimensional array is, well, first let's call it list2, and let's set it equal to square brackets again. But this time we're going to hit enter. So you'll notice that it auto formats for us so that we have this nice kind of indented section here, and we're going to add another set of square brackets. So why don't we just add in our first list here? So whatever you entered into your list 1, let's do 1, 2, 2.3, or whatever numbers you're entering in there. And then we're going to finish with our date. So I'm going to do 2024-01-01. We're going to go to the right of our square brackets there, and we're going to add a comma, and then we're going to hit enter. And then we're going to create another list. So feel free to enter in whatever you want to. I'm going to type in the word 5, and then I'm going to put in the integer 1, and then I'm going to put in a float of 7.8. All of these are comma separated. My apologies for not saying that. And then I'm going to enter in a date of 2022-10-01. Let's add in one more list. So we're going to go to the right of our second list. We're going to add a comma. We're going to add square brackets, which is where we will put in our final list. And then we're going to do another string. So this time I'm going to do Steve. I'm going to go to the right. I'm going to add a comma. I'm going to hit space, and I'm going to enter an integer. I'm going to do 7. I'm going to do a comma. I'm going to hit space, and I'm going to do 1.2. I'm going to do a comma, and I'm going to do space, and I'm going to do one final date. I'm going to do 1985-12-01. Cool. So now we have a list of lists, also known as a two-dimensional array. We're going to enter in a print command, and then we're going to print out list_2. So before we run the cell, let's talk about the difference between a one-dimensional array and a two-dimensional array. So in the one-dimensional array, we only have one access point, right? Because there's one list. But in the two-dimensional array, we have a list of lists, which means we have two access points, the list item and then the values within the list. Both of these are 0 indexed. So for example, if we print list_2, you can see that now we have two square brackets next to each other, and then we have 3 lists that are comma separated, and then at the end we have 2 square brackets. So if we go to list 2 and we add a square bracket and then we type in 0 and we hit play, check it out. We get the first list in our list of lists. Now, if we add another square bracket and we add in 1, we are going to get the first list and the second item in the first list, right? Or maybe a more articulate way of putting it is you're getting the second value from the first list. So the reason that it's two-dimensional is because when you have a one-dimensional array, you only have one access point because there's only one list to reference. But when you have a list of lists, you have 2 dimensions to access, the list and the item within it. So if you want to play around with this, all you have to remember is that lists are 0 index, regardless of whether they're 1 or 2 dimensions. If you're dealing with a 2-dimensional array, it's known as a list of lists. So the first value that you're entering in is the list that you want. The second value is the item within the list that you want to access. The next section that we are going to be addressing is going to be how to build dictionaries. We're going to add another code block. So dictionaries are dictionaries allow you to associate values with keys. So you can establish value key pairings. So we're going to build a variable of dict _1, and we're going to have it be equal to curly brackets. We're going to hit enter. And we are going to add, let's do single quotes, and I'm going to enter dad. And I'm going to go to the right. I'm going to add a colon. I'm going to hit space. I'm going to do single quotes. I'm going to type the word Joe. So in this case, we are associating the value of dad with the value of Joe. We are going to be adding single quotes and the word mom. We're going to go to the right of that. We're going to use a colon. We're going to hit space, and we're going to do single quotes again, and we're going to type in the word Joe. We're going to do comma, and we're going to hit enter. So we're going to add one more set of values in here. We're going to use brother. We're going to go to the right of it. We're going to use colon, and we're going to do single quotes, and then we're going to enter in the word Phil. So this is one version of a dictionary. But another way to associate it is a dictionary with lists, which is also known as keys and values. So this is where the key and value pairing becomes more apparent. We're going to begin by using the same prefix, but instead of doing an _1, we're going to be doing an _2. We're going to set it equal to curly brackets, and you know what? Let's change that name. Let's just go with combo. And we are going to have it be curly brackets. We're going to hit enter, and instead of entering in those names, we're going to use single quotes, and we're going to type the word person. And we are going to use a colon, a space, and then we're going to use a square bracket, which means that we are building a list. So instead of typing out Joe, Joan, and Phil individually, we are going to make them be in the same list. So our first value is going to be Joe, single quote, we're going to do comma, space, single quote, and then we're going to do Joan, and then we're going to do comma, space, single quote, and we're going to do Phil. We're going to go to the right of our list. We're going to use a comma. We're going to hit enter. And then we're going to use single quotes again. And now we're going to call it family type. And we're going to go to the right of our single quotes, and we're going to use a colon. And then we're going to use square brackets. And we're going to type in dad, comma, space, single quote, mom, comma, space, single quote, brother. And now we have a dictionary called combo, where we have keys of person and family type, and then we have values that are paired with one another. So now if you call person, you can associate Joe with the family type of dad because they are both the first value in their lists. Same thing with Joan and mom, and Phil and brother. When we get to our section on replacing values, using these dictionaries, these key value pairings, is going to be a very efficient way to start remapping data and cleaning data. Cool, so now we can start working with the Pandas library. So we are going to learn how to import Pandas. So we're going to highlight it, we're going to do bold, we're going to do our big T's, and then we are going to add a new code block. So the thing that might be new about Python for beginners is the importing of libraries. So Pandas is an external library that is maintained by a group of people. So these are like living, breathing programs that you can install into your workspace. So to start using Pandas functions, you have to import it. So we're going to use the command import, and you can see that it is highlighted as or colored as purple to show you that it's a command. And then we're going to type in pandas. And then we're going to cast it as PD, which you can see as a suggestion here. Now, I don't really know why we cast it as PD. My presumption is that it's just more efficient to type PD instead of having to retype pandas. I generally think casting, so basically importing something as something, is really beneficial. I do it with pretty much all of my modules for efficiency, as well as for in the event that I need to change something, I can keep the reference while changing the primary import. But that's something that you don't have to worry about now. For the time being, all you need to do is import pandas. So next thing that we're going to do is learn how to build data frames. So this is where the panel data portion of Pandas comes into play. So right now, like you saw when we were like, let's actually scroll up a little bit because we didn't run this cell yet. A lot of these cells we didn't run. But like if we try to print combo, you can see that it comes back as a dictionary, right? So this isn't in row and column formatting. But when you want to start, modifying data and, doing math functions on data and changing values and all that type of stuff, there's functionality within Pandas that you want to use. So what we're going to do is we're going to use this combo dictionary, and we are going to create our first data frame. So we are going to use the variable of df underscore combo, and we're going to set it equal to pd.dataframe, parentheses, and then we're going to pass in combo. The reason that we're passing in combo is because that is the variable declaration that we made with this dictionary. Now, if we try to run this, we will probably get an error because we didn't run this import pandas cell. So I just want you to see that real quick, just so that you can kind of get used to notebooks. So you can see we got an error where name PD is not defined. That's because this cell has not been run yet. And you can tell if a cell has been run because it'll have a check mark next to it. So you can see we built this how to build dictionaries cell had been run, so it's up to date and it's available to be used. But we haven't run these other cells over here, so we're getting an error. So what we're going to do is we're going to go up to runtime here, and here's where you have the ability to run various cells, right? So you can run them all. You can run all the cells before this one. You can just run this cell. You can run a selected cell. So we're just going to select run all. And now you can see we have all of our check marks, and that error has gone away. Cool. So now we're going to print df underscore combo. And check it out. Now we have that dictionary is being formatted in a 0 index, right? So you can see that the first row is 0 and the third row is 2. And you can see that our headers are person and family type, which is the keys that we associated with our values. The next thing that we're going to learn is how to build data frames with lists. So there are going to be times where you will, have lists that you want to pass into data frames. So I do a lot of SQL work So I'll run SQL code. Like I'll query the company that I work for. They have a database. I'll query the database from my Python script, and then I'll pass the values into a data frame so that I can blend the data, clean the data, adjust the data, whatever I need to do with it, right? And the majority of the time, the data is coming out of the database as a list. That's just the way that I've formatted it. There's other ways that you can do it. Long story short, this section is going to touch on using lists to build out data frames. So the first thing that we're going to do is declare our headers. So we are going to create a variable called headers, and we're going to set it to a one-dimensional array, also known as a list. So we're going to do person, comma, single quote, age, comma, space, single quote, location. We're going to go to the right of our list. We're going to hit enter twice. Next, we're going to declare our values. So we are going to call this variable family, and we're going to set it equal to square bracket. And then we're going to hit enter. Oop, my apologies. We are going to hit enter, and we're going to be building a list of lists. So our first list is going to be a string, and it's going to be dad. The second value is going to be an integer, and the third value is going to be a string. So you can enter in whatever you want to. I entered in dad, 75, and Texas. Feel free to follow along with me. We're going to go to the right of our list. We're going to enter in a comma. We're going to hit enter. We're going to have a second list, and this one is going to be mom. We're going to use a comma. We're going to enter in an integer. We're going to use a comma, space, and then we're going to enter in a string. I'm going to enter in Florida. We're going to go to the right. We're going to add a comma. We're going to hit enter. And then we're going to add square brackets. We're going to do single quotes, and we're going to do brother, comma, another string or another integer, and then one final string. So you can enter in whatever you want to. These values don't really matter. I would just recommend that you use 3 keys. So person, age, location, do whatever you want to. It doesn't matter. You can follow along with me, or you can type whatever you want to. It's really up to you. Now we're going to build our data frame. I'm going to hit enter, and now we're going to use df, and we're going to set it equal to pd.dataframe. And I just want to mention this is case sensitive, so it has to be capital D and it has to be capital F. We're going to use open parentheses, and now we're going to declare our columns and data. So just for a moment, you can see for our first data frame, when we used a dictionary, you can see we just passed in the value of combo. So if we just entered in family, because that's what our values are, and then we printed df and we run it, you'll notice that we're getting our rows, but our keys have not been added as columns. So when you pass a value to a data frame, it is going to default to being the data or the values. So the cool thing about Python is that you typically have a lot of functionality. So instead of just passing in data, you can declare columns and set it equal to, and in this case, we're going to do headers. And then you can use a comma, and then you can type in data, and you can set it equal to family. And then if you run your cell again, you'll see that we now have our keys up top, which is person, age, and location coming from our first list, and our rows are populated with our values coming from the family list of lists. This is a really cool thing about Python. It's very much like having a bucket of Lego blocks. So you can build whatever you want to. You have total freedom to create, right? So if you're coming from a spreadsheet background, that's similar to buying a model, right? Where it's like a Marvel box of Legos. You have the exact amount of pieces needed to build the model that is in the box that you bought. With Python, you're basically just buying a bunch of Lego pieces and you can build whatever you want to with them. It's very freeing and there's a lot of creativity that comes with it. Cool, so now let's learn how to sort data frames. So I'm going to build another text block. I'm going to do how to sort data frames. Okay, so I guess let's just keep it nice and simple. So let's use that same data frame that we were using, and we're going to set it equal to df.sort_values. And the way that you use sort values is you say by and you set equal to. And then I like using a list. That way, if you want to, you can sort by multiple things. But we're going to begin by sorting by location. So we're going to hit enter and we are going to print our data frame. And check it out. So this is now going in ascending order, right? So you can see dad was originally the first row, followed by mom and brother. Now mom is the first row because we're sorting by Florida, followed by New York, and followed by Texas. So when you use sort values, that defaults to ascending order. Very much like with our data frame example, you have more control than that. So if you go to the left of your list and you add a comma, and then you type in ascending equal to, you can do capital F false. And when you run it, you will then have a descending order of values. Now, it gets even cooler than that in that you can also sort by multiple values. So just so you can see, I am going to change dad's location to Florida. So take a moment if you're using my example and have it so that your first list and your second list have the same location or the same third value or whatever it is. So what we're going to do now is we're going to rerun our cell with our data. So you can see dad and mom are now Florida. And we go down here and we'll rerun this cell. And now you can see that brother is now the first one because he is in New York and we are sorting by descending values first, and then it's followed by dad and mom. Now, in addition to sorting by location, we are going to sort by age. And now that we have two values in there, we also have the ability to sort those values in ascending and descending order by each value that we are sorting by. So we're going to delete false and we're going to add a square bracket, which means we have a list. So now we can pass in more than one value. So we are going to sort by location in ascending order. So that's going to be true. And we want to sort by age in descending order. So we're going to enter it in false. So what's going to happen when we print this is Florida should come before New York, but dad or mom, because 75 is older than 70. So we're going to hit run and check it out. We now have that where we are getting an ascending location and a descending age. And then if we wanted to just order by ascending, we could either change that false to true, or we could just delete it because sort values defaults to ascending. So you can see we are now sorting by age. Mom is first because her age is lower than dad's. 70 is less than 75. Florida is coming first because it comes alphabetically prior to New York. Our next module is going to focus on how to replace values. So we're going to highlight that, we're going to turn it into a section, and then we're going to add a new code block. So the first thing that we're going to learn is how to replace one value. So we're going to continue with our data frame example, and we are going to change a person's name. So we're going to say df, and then we're going to use a list, and then we're going to pass one, or square brackets, I should say, and we're going to pass in the person we're going to pass in person because that's our first column, right? You can see up top here, person. We could also do age or location if we wanted to. But for this example, we're going to do df is equal to person. And we are going to use an equal sign, and then we're going to type df square bracket single quote person. And then we are going to do dot replace, and then we are going to have parentheses, and we are going to replace single quote dad, comma, single quote Joe. So the first value that goes in there is the thing that you want to replace, and the second value is what you want to replace it with. So when we print out df, you can see now instead of dad appearing in there, we have Joe. Now, much like our prior examples where we use, two values, you can also replace more than one value. And in order to do that, you're going to use a list. So we're going to use a similar example there where we're going to do df single quote person within a square bracket, and we're going to set it equal to df square bracket single quote person dot replace, and then we're going to have parentheses. Now, instead of, and I apologize, I think I said a list in there. We're not going to use a list, we're going to use a dictionary. My apologies if I said that. We're going to use curly bracket, and then we're going to do single quotes, and we're going to type in mom. We're going to go right of the single quotes, and we're going to use a colon, and then we're going to pass in whatever value we want to change it with. So in this case, we're going to do Joan. Fun fact, that is not my mom's name, but that's what I went with. So we're going to use a comma after Joan, and then we're going to do single quotes, and we're going to do brother. We're going to do the right of that, and we're going to use colon, and then we're going to use single quotes, and then we're going to type in Phil. Another fun fact, these are not my parents' or brother's name, and it's not where they live, but I thought it'd be fun for this lesson. Anyway, we're going to do print parentheses, and then we're going to print our data frame, and check it out. Instead of having dad, mom, and brother, we now have Joe, Joan, and Phil. Cool. So as I said earlier, we also have the ability to replace the values using a dictionary. So what we're going to do is we're going to declare a dictionary called names, and we're going to set it equal to curly bracket, and we're going to hit enter. Then we're going to use single quotes, and we are going to type in our key pairs. So we will do, actually, you know what? I'm going to show you just how to use it with dictionary, like the first dictionary that we used. So we're going to do single quote dad, and we're going to use a colon, and then we're going to do single quote, and we're going to do Joe. We're going to do a comma. We're going to hit enter. We're going to do single quote, and we're going to do mom. We're going to go to the right. We're going to use a colon. We're going to use single quote, and we're going to do Joan. We're going to go to the right. We're going to use a comma. We're going to hit enter, and we're going to enter in brother. We're going to go to the right, add a colon, single quote, Phil. So now that we have a dictionary of names, we can replace the values with the names dictionary. We're going to hit enter, and we're going to do pretty much the exact same thing that we just did. So we're going to reference df, square bracket, single quote. We're going to reference the person column. We're going to set it equal to data frame, square brackets, person dot replace. And then we use our parentheses. And then we're going to reference names. Oh no, you know what we're going to do? Well, yeah, we're just going to reference names. My apologies. And we're going to hit enter, and we're going to hit print, or we're going to say print, and then we are going to reference our data frame. Now, before we do this, let's go back to how to build data frames with lists. Actually, you know what we'll do? We'll do the easy thing. Because we already replaced our values in here, we're going to comment out. So highlight the dfperson.replace from the replace one value and replace with more than one value, such as I have it on the screen, and then we're going to comment it out. So remember, use Control or Command and then the slash. So it should be highlighted, or it should be commented out now. We're going to go up to the menu, and we're going to hit Runtime, and we're going to run all. And now you can see we have successfully implemented our replace values using a dictionary. Now, the reason that I had us run all was because this is kind of one of the things with notebooks, is it stores things to memory. So when we had our data frame up here and we replaced all the values, if we attempted to use this names dictionary as we did, dad, mom, and brother already would have been gone because we replaced them in this code line and this line of code here. So the reason that I commented it out and ran it was to show you that we can use this dictionary example here in order to replace using just the names variable. Now, the last version of replace that we are going to use is going to be replace the data frame with key pairs, right? So this is the second version of a dictionary that we learned that we called combo. Now, we could use the combo variable, but I want you to get the reps of building these things out so that you start to kind of understand how they're built. So we're going to create a new variable called key underscore pairs, and we're going to set that equal to curly brackets, and we're going to hit enter. The first thing that we're going to enter is the word family in single quotes. We're going to go to the right of the single quotes and use a colon. We're going to use square brackets in order to develop a list. We're going to use single quotes and enter in dad, comma, single quotes mom, comma, single quotes brother. We're going to go to the right of our list. We're going to add a comma, and we're going to hit enter. We're going to use another set of single quotes, and then we're going to use the word name. We're going to use a colon, space, and then a list. We're going to enter in Joe, comma, Joan, comma, Phil. All of those values being encased in single quotes. We're going to leave our dictionary now, and we are going to replace the values with our key pairs. We're going to hit enter, and we are going to say df square bracket person. And we're going to set that, we're going to set that equal to df square bracket person dot replace open parentheses, and then we're going to reference key underscore pairs, and then we're going to use square brackets, and we're going to reference single quotes family. We're going to go to the right of our square brackets, and then we're going to reference key underscore pairs again using square brackets, and then we're going to use name. We're going to hit, we're going to hit enter, and then we are going to print our data frame using, actually, you know what we're going to do real quick? We're going to highlight replace the values with the names dictionary section and the replace the values using a dictionary section. So you should highlight the previous example using a dictionary, and we're going to comment all that out. And then we are going to use our runtime again, and we are going to run all. And you can see that, again, we have successfully renamed or replaced our values using a dictionary. So there's many ways to do these things. I wanted to introduce you to all of them so that you can determine which one works best for you. I use variations of all of these. It really just depends on what the situation is and what I need to do. Cool, so now we are going to learn how to add columns. So we are going to continue using our data frame example. So we're going to create a new code block here in our how to add columns section. And we are just going to add one column to the data frame. So we're going to do df and then square brackets, and we're going to use single quotes, and you can enter in whatever you want to. I'm going to do new name. Feel free to use that if you want to. And you can now set this equal to whatever you want to. So we're going to do single quotes. I'm going to say, hey, is this thing on? And I am going to go to the right. I'm going to hit enter, and I'm going to print my data frame. And then I am going to run my cell. And now you can see I have one of the most useless columns there is, but I added a new column. So in addition to our person, age, and location, we have now added a row with the string of, hey, is this thing on, to every value in our data frame. So now that we've added a column, we are going to learn how to remove columns because we do not need that. It doesn't serve us any purpose. We are going to add another code block in here. So we are going to learn how to drop one column. So we're going to do DataFrame is equal to df.drop parentheses columns equal to square bracket new name. We're going to hit enter and we're going to print our data frame, and then you'll see that we are now back to our original data frame. So now we are going to drop more than one column, and we're going to set that equal to df is equal to df.drop parentheses columns equal to, and then we're going to use square brackets, and then we're going to drop location comma single quote h. So we might have an issue here because we've already dropped new name. So when we rerun this, it might say you've already dropped new name. Yep, that's exactly what happened. So we're going to highlight this. We're going to comment it out, and then we're going to rerun our cell. Oh, sorry, I forgot to print it. So we're going to hit print df, and we are going to run our value. Okay, so basically what appears to have happened is that the entire cell executed, so we've removed location and age already. So what I'm going to do is we are going to uncomment our df is equal to df.drop columns equals new name. So what we're going to do is we are just going to have our runtime run all, and you can see that now it executes successfully, right? So in this code block, we add our column. In this new code block, we've removed all of our columns. I don't know if you recall, but at the beginning of the video, I talked about some clunkiness. I typically do not code in notebooks like this. It's just not how my mind works. But if you are getting errors like that and your syntax is correct, try rerunning the entire script or the previous code blocks because you might have overwritten something. This actually is a good time to note that you'll notice that I am consistently overwriting the data frame variable, the df variable. I just want to mention that like df is definitely how documentation will reference like pd.dataframe, like using df as just kind of like a placeholder, the way that people use x and y as a placeholder variable. As you get deeper into your Python journey, you're going to want to be more intentional with your variable naming, especially as it relates to data frames. I've seen a lot of code from, some like I've adopted code from people, and they'll have like df equal to, and then they'll have like df2 equal to and df3, and it's very difficult to understand what the data frame is actually doing and why it's there. So I would recommend, like, it's great to use df so that you know it's a data frame, but use underscores or other naming conventions so that people understand that, like, this data frame is family, or this data frame is names, or what have you. Additionally, it's fine to overwrite things, but as you start to kind of like build out, you can use new variables so that you don't completely delete data. I plan on kind of talking about that in future videos where we have a more sophisticated project. But for the time being, I'm comfortable with this practice of df is equal to, just so that you can kind of get the swing of things. But I do want to make you aware of just kind of like not in the future kind of like building on that, having that as like a learning opportunity. Cool. So now that we only have one column, I think the next logical thing to do is how to add columns. And we're going to do that with merge. So we're going to bold this out. We're going to double those T's. We're going to add a code block in here. So in order to add columns, you're going to have to create a new data frame. So we are going to create data you want to add. We're going to hit enter, and we're going to call this data underscore merge. and we're going to set it equal to a dictionary. And we are going to have single quotes, and we are going to type person, and we're going to go to the right of the single quotes. We use a colon, and then we're going to enter in some names. So we are going to use Joe, single quote Joan. We're going to go to the right, and we're going to use Phil. And we're going to use comma, and we're going to hit enter, and then we're going to type in new data. And we're going to use colon, and we're going to use a list, and then we're going to enter in some integers. So I'm going to do 100, comma, 250, comma, for 540. Cool. So what we're going to do next is we are going to create a new data frame, and we are going to set that to new underscore data frame, and we're going to say pd.DataFrame parentheses, and we're going to pass in data underscore merge. Cool. So now we are going to merge the new data frame with the existing data frame. And we are going to say df is equal to df.merge. Oops, sorry. And we are going to do new underscore data frame, comma, and then we're going to say how is equal to single quote left, and then we are going to say on is equal to person. We're going to hit enter, we're going to do print, and we are going to print our data frame. Check it out. We now went from Joan, Joe, and Phil to having a new column called new data. So there's also like this example is one where you have an existing set of data that you want to merge to another data frame where you have a common column name, right? So you can see right here we have in our existing data frame, there's a key called person, and there's the exact same key in the data merge data set, which becomes new data frame. But let's say that that was called name instead of person. So if we try to merge with this code, we're going to get an error, right? And the error on here is saying the key error is person. And that's because we can't merge on person anymore. So like we've seen in other examples, Python has a lot of functionality. So now that we have this new name up here, what we're going to do is add a comment and say merge when the key is not the same. So you're still going to have the need to have values, like Joe needs to exist in both in order to merge on it. But what you can do is DataFrame is equal to DataFrame.merge. So it's all the same stuff that we just did. And we're going to use new underscore DataFrame, comma, and we're going to say how is equal to single quote left, comma, oh, sorry, outside of the single quote. And then we're going to do on, and we're going to set it to, or no, sorry, we're not going to do on. We're going to do left underscore on. And we're going to set that equal to person. The reason for that is because left is always the first data frame that you're using. So because DataFrame.merge comes first, we are going to say left on whatever its key is. So you can see DataFrame has a key of person, whereas our right value of new data frame coming from data merge has name. So we're going to use comma, and we're going to say right underscore on is equal to name. So we're going to comment out this line here because we've already merged on that and we don't want that data anymore. I want you to see new data. Actually, you know what? We're going to change this from new data to just data so that you can see the difference. And once you've commented out this line, we're going to go up to runtime and we're going to run all. And my apologies, we're going to print our data frame. So we're going to go back up here and we're going to run all. And check it out. We now have person, name, and data. So that's kind of what we want, right? But we don't want that duplicate column there of name. So after our merge, we're going to use dot, and then we're going to say drop, and we're going to use parentheses, and we're going to say columns is equal to, and then we're going to drop name because we don't want it. So we're going to go up to runtime, we're going to run all, and check it out. We have now merged two data frames where the pair value, or the key pair, has a different name using left on and right on. We also learned how to use this when we have the exact same key value there. So again, there's a lot of versatility as it relates to merging data and leveraging Pandas. So we're going to learn how to add rows. Create a new code block. And we are going to add some values to our existing data frame that has two columns, a name and data. So we're going to create a new dictionary for our rows. So we're going to say new underscore row underscore data is equal to curly brackets. And then we're going to do single quotes of person, and we're going to go to the right, and we're going to use colon, and then we're going to use list, and then we're going to type in some names. So we're going to do Hallie, comma, Molly, comma, and Patty. We're going to go to the right of our list, we're going to use a comma, and then we're going to type in data. We're going to use a colon, and we're going to use a list, and we're going to type in 750, comma, 765, comma, 345. Cool. So now we have our data frame, we have our dictionary, and we're going to create a new data frame. So we're going to use new underscore rows, and we're going to set it equal to pd.data frame, and then we're going to pass in new underscore row underscore data. I'm going to hit enter, and then we are going to concat the data frame with the new rows data frame. So we're going to hit enter, and then we're going to say df is equal to pd.concat, open parentheses, we're going to use square brackets, and then we're going to type df, comma, new underscore rows. We're going to go to the right, dot reset underscore index, parentheses, drop equals true. Hit enter, print df. So the reason that we did reset index drop equals true is because when you add two data frames together, it will give you a different index. So you know what I'm going to do? I'm going to remove this. I'm going to copy this and remove it. You don't have to. I'm going to go up to runtime, and I'm going to run all. And now you can see that I have added new rows to my data frame, but check out the index over here, right? We have 0, 1, 2, 0, 1, 2. That's because Hallie is 0, Molly is 1, Patty is 2 in this new data frame. So when we add in dot reset underscore index drop equals true, what'll happen is actually, you know what I'm going to do? I'm going to remove this so you can see how that works if you don't have drop. So we're going to run all, and now you can see that the original index has been added into the data frame. So now we have 3 columns instead of 2, kind of similar to what we ran into when we were using merge up here, where we had person and name columns when really we didn't want names, right? So you can see here we use drop. So instead of having to use drop, we're going to have drop equals true within the reset index argument. And then when we go to runtime all and we run them all, you'll now see that we have a reset index and just 2 columns instead of 3. Cool. So now that we know how to add columns and add rows and replace stuff and do all this stuff, we're going to learn how to search rows. So I find this to be one of the most powerful things to learn how to do, because when you are auditing large sets of data, this is a really quick way to find the thing that you want to. So we're going to create a new variable called searcher, and we're going to set that equal to df.query, and then we're going to use open parentheses, and then we're going to use double quotes. You've noticed throughout, or maybe you haven't, but throughout this entire lesson, I've tried to use single quotes. It doesn't matter if you use single quotes or double quotes. The only thing that matters is that you remain consistent. So try to use uniformity throughout your program so that it's just easier to bug correct and to make sure that everything works with one another. The reason that I'm using double quotes is because we're going to have to use single quotes within query. So for example, if we are searching for a person, we're going to use double equal sign because single equal sign, you'll notice up top here, like here, here, and here, when you use single equal sign, that's a definition where you're basically saying this word is this other word. Whereas when you use double equal sign, it's an evaluation, right? So you're saying when this value matches this thing or is this thing or what have you. So we're going to use person, double equal sign, and then single quotes. You want to make sure you have two single quotes here. And within them, we're going to type in Hallie. And I forgot to do print searcher. And now you can see we've returned the row with Hallie. So let's say that we want to search for people when their name is Hallie, and then we're going to use an ampersand, and we're going to say, let's try and do person equals Molly. So that's going to be inside single quotes. Sorry, that doesn't work because you would need to have a person that is equal to Hallie and Molly, which is not possible. So you know what we're going to do? We're going to use a bar there, and that's how you say or. So we're going to try running this, and now you can see we're getting Molly and Hallie. So let's do amount. So we're going to do data is less than or equal to 35. So we just get Hallie. So let's do 350. And now you can see that we're getting a more dynamic result where we're getting Hallie and anyone who has a value under 355. So now let's do only people over 350 and Hallie. And now you can see we're getting Phil, Hallie, and Molly. So this is a really cool way of searching things. There's lots of different ways to search rows. This is my preferred way because I just really like query syntax because you can use or and. So I don't really have any great examples in here of using the and. So this data as it's constructed was great for or. But for like in the event that you need to, you can just use an ampersand like this and you can have and or. You know, I'm going to focus on specifically just query in other videos. When you're using or, it can create more ambiguous results. So learning how to use parentheses with or statements is going to be really important if you start having something where you're saying and or in the same query statement. Cool. So the last thing that we're going to touch on today is how to do math. So my apologies, we got two of these now. So this section is how to math. We're not going to go super into it, but this is just going to kind of teach you the basic principles in here. So we're going to say math is equal to, and then we're going to use df.groupBy, and then you can declare grouping by, and you're going to say equal to, and then we're going to use square brackets, and we're going to use person, and then we're going to say dot sum, and we are going to reset underscore index for the same reason that we did reset underscore index above. So right now, we are going to also print math. Right now, we don't really have anything to sum by, you know, because we just have one row of data. So what I'm going to do is I am going to rerun my how to add rows. And now you can see we have 2 rows with Hallie, 2 rows for Molly, and 2 rows for Patty. So what should happen now is when we run this math function, you can see before it was Hallie is at 750. Let's rerun searcher just to make sure. You can see now we're getting 2 results for Hallie in here instead of 1. And when we run this, we should get 1500 for Hallie, right? So you can see we have multiple lines now, and we have an increasing number because of sum. So in order to do math aggregations in here, you need to use group by, and then you need to declare what you're grouping by. And the same way that we learned above how you can have more than one thing that you're grouping by is the same thing that you can use in the group by method in here. So if you want to do a sum, that's how you add things. If you want to use mean, that's how you get average. You can see that now it's changed into a float instead of an integer. And then you could also get median. So there's lots of different things that you can use in here. And yeah, I think I'll focus more on math and query and some of these other things in other videos. But you know, this was meant to be a beginner video, and you know, I've been using Python for probably about 3 or 4 years now. You know, I'd been in spreadsheets for a while, and I kind of started dabbling with AppScript, and then I learned it over winter break one year, and my career was never the same for all of the reasons that I would ever hope. It's really taken me to the next phase of my career and development, and it's allowed me to pursue some of the most exciting and fulfilling and satisfying projects that I always hoped that I would be pursuing. And the way that I learned it was through YouTube videos. So my aspiration with this video was to provide the same opportunity that I had to other people. And I hope that you found this helpful, informative, inspiring, and that it's the first step to you reaching that new point in your career. So if you do have any questions, please reach out in the comments. My email's in my About section. I love hearing from you all, and I wish you the best of luck with your journey.